Welcome to the class activities for lesson number 9. So I hope you've had an opportunity to try each one of these equations in the inequality that's here. Let's take a look at the first one. What's important is that when you look at an equation, you can sort of categorize it, put it into a classification for the type of equation it is. So when you look at this first equation, you see that it has a radical in it, so it's a radical equation. Remember, your goal is to get the radical on one side of the equation and everything else on the other. Well, as you can see, the radical is already on the left-hand side. So the first job we have to do here, since the radical is already isolated, is to square each side to remove the radical. So remember, squaring and square rooting undo each other because they're inverse operations. So we're left with 5x plus 10 on the left side. And once we square x plus 2 on the right side, we get x squared plus 4x plus 4. Remember, x plus 2 squared equals x plus 2 times x plus 2. And that gives us that trinomial. Okay, now we say what kind of equation do we have? And we have a quadratic equation. So we know to solve quadratics, we have to get 0 on one side and all the other terms on the other. So we're going to remove the 5x from each side by subtracting it. 10 equals x squared minus 1x plus 4. And now I'm going to remove negative 10. I'm going to remove the 10 by subtracting it. So I get 0 equals x squared minus 1x minus 6. So now your job is to solve this equation for x. And you can do that with your quadratic formula, or if possible, and it's easy to do, to factor this. So I'm going to factor x squared minus 1x minus 6. And I know that the signs are opposite since my 6 is negative. So I'm looking for factors of 6 that differ by 1 because I have a subtraction sign right here. So I say factors of 6 that differ by 1. And it's 3 and 2. And I put the 3 after the subtraction because when I add my middle and outer term here through my distributive property, I end up with minus 1x. So now I set each factor equal to 0, and from there it's a one-step process to solve for x. I get x equals negative 2 and x equals 3. So my instructions ask me to check this either graphically or by plugging in. So I'm going to check it algebraically by plugging it in. So I go back to my original equation and I say 5 times negative 2 plus 10. The question is, does that equal negative 2 plus 2? So let's take a look at that. So I get the square root of negative 10 plus 10. Does that equal 0? Well, the square root of 0 equals 0. So that's one of my solutions. Now let's check the other solution. The square root of 5 times 3 plus 10, does that equal 3 plus 2? Square root of 15 plus 10, does that equal 5? Square root of positive square root of 25 is 5. So they both check. You could circle both answers. And as you know, your book asks you for the solution set. So you use your curly braces. You put the negative 2 comma 3. Those are your two solutions. Okay, the next problem is a problem that has a rational exponent. So again, we want to isolate that, but it's already isolated. It's already on the left-hand side of your equation in this case. So our goal is to make the left side say x plus 5 to the first power. So again, we use that handy dandy number called the reciprocal, and we raise this to the 2/3. And whatever we do to one side, we must do to the other. And this gives us number 1 when we multiply a number 3/2 times its reciprocal. So the left side is x plus 5. And then the right side is the cubed root of 8, the whole thing squared. So that gives us 2 squared, which is 4. So x plus 5 equals 4. One step, we subtract 5 from each side and we get x equals -1. So let's check that. Go back to our original equation. Always, we put in the solution that we think we have. -1 plus 5 is 4. 4 to the 3/2 equals 8. This is our question. The square root, that tells us the square root of 4 is 2. 2 cubed is 8. 8 equals 8. We're happy. So -1 is our solution here, and the solution set would consist of just the number -1. 3 is a compound inequality. As we talked about earlier in the demo, we want to work from the middle out to get an x in the middle of this inequality. So first we're going to remove the addition of 3 by subtracting 3 from each side of this inequality. So we have -3 is less than 3x, which is less than or equal to 24. To get x, we divide everything by 3. And we get -1 is less than x, which is less than or equal to 8. So on the number line, that would look like this, -1. We'd have an open circle. We'd shade everything up to 8. We'd close the circle at 8. So it's this entire set of numbers between -1 and 8, with 8 being included in that set. So in interval notation, we would put parenthesis -1, comma 8 with our bracket. So this is our solution set to that inequality. And again, you could take any number in this interval, like 0, for example, put it in for x, and you see that you would have 3 is less than 27 and 3 is greater than 0 if you had x equals 0 here. So you know you're okay with that solution set. Okay, 4 is another radical equation, but here we have to do a little bit of work before we can isolate the radical on the left side. So let's subtract x from both sides. And when we do that, we've isolated our radical. We just have radical x minus 4 on the left side, and we have 6 minus x on the right side. Okay, to remove the radical, we do the inverse operation of square root by squaring, and then we square the right side. So we have x minus 4, and when I square 6 minus x, I get 36 minus 12x plus x squared. Again, 6 minus x squared is 6 minus x times 6 minus x. And if I use my distributive property twice, I end up with this trinomial, these three terms. Again, I have a quadratic equation. So to solve this, I need to get 0 on the left-hand side. So I'm going to subtract x from both sides. And I get -4 equals 36 minus 13x plus x squared. And now I add 4 to both sides. And I get 0 equals 40 minus 13x plus x squared. Now all I'm going to do on the right-hand side here is write the right-hand side, this expression, in descending order by putting the highest power first, and then my next power, and then my constant term. Now again, I can use a quadratic formula, or I can factor. This is a very easy factoring problem because I'm looking for factors of 40 that add up to 13, and those are 8 and 5. And I know that the signs in my parentheses for each factor, the operations in here, the operation is subtraction. So now x minus 8 times x minus 5 has to be a 0. So either x minus 8 is 0 or x minus 5 is 0. And it's a one step from there to solve your problem. But are you done? No, you have to check. Every radical equation has to be checked because we could introduce an extraneous solution. So let's go back to our original equation and check each one of these solutions. So here's our original equation, equals 6. Okay, so my first solution is 8, so I'm going to check out the 8. Is 8 plus the square root of 8 minus 4 equal to 6? That's our question. 8 plus the square root of 4, does that equal 6? 8 plus 2 does not equal 6, so 8 is extraneous. Let's check out the 5. Hopefully that will work. So we have 5 plus the square root of 5 minus 4. Does that equal 6? 5 plus the square root of 1. Does that equal 6? 5 plus 1 equals 6, because 6 equals 6. You're happy. So the only solution here in your solution set is the number 5. 8 is extraneous. So one of the things the directions said was to check your answers graphically. And how would you do that here? Well, you could use a graphing calculator, or you could use GeoGebra. And we've had some practice with GeoGebra now, but let me just show you how you could check something like number 4 with GeoGebra. Well, let me finish number 5, and then I'll do that at the end, for those of you who aren't interested in seeing how it's done graphically and you just want to work through these algebraically. Well, number 5 is another inequality. This time it's not a compound inequality, but you see those little fractions there and you say, what do I do? Well, again, similar to an equation, you have the right to multiply both sides of an inequality by the same non-zero quantity. So why not multiply both sides by the number 6, and that will make all of the terms in this inequality have 1 in the denominator, which will make it a lot easier to solve. So my lowest common multiple in this case is 6. So I'm going to take 6 and I'm going to multiply each of the pieces of my inequality by 6. So I multiply the left-hand side by 6 of my inequality, and then notice I have 2 terms on my right side. So I need to multiply both of those by 6 in order to keep this the same inequality, an equivalent inequality. So let's see here. Just trying to work with my colors so you can see changes I'm making. And we have 6 times 5 over 6. So the beauty of using 6 is that 2 is a factor of 6, so 2 goes into 6 3 times. Notice we get 1 in the denominator, so this becomes 3 times the quantity x minus 4 is greater than or equal to, and then we have 3 is a factor of 6. 3 divides 6 twice, so we have a 2 there, so now we have 2 times x minus 2, and then we have 6 divides into 6 once, so we're left with a 5. So there's a linear inequality we have to solve. It's a lot easier to think about for most of us than seeing the fractions here in the original equation. So we use our distributive property and we get 3x minus 12 is greater than or equal to 2x minus 4 plus 5. So my left side's already simplified, so I keep that as it is. My right side, I can combine the negative 4 and the 5 to get 2x plus 1. So now to solve this, think about this as having an equal sign there. And you would get your x's on one side and your constants on the other. So I'm going to add 12 to both sides. And I have 3x is greater than or equal to 2x plus 13. And now I subtract 2x from both sides. And I get x is greater than or equal to 13. So if I write that in interval notation, I use my bracket because it's equal to 13. 13 is included as part of my solution. So from 13 to infinity, on the number line, I would put 13 with a solid dot and color it all the way out forever and ever to the right as it moves towards infinity. So those are the 5 equations that we had in the demo for this particular part of the course. Please let me know if you have any questions. Okay, so let's take a look at this number 4 graphically to see how we would solve it. And if at this point you want to stop the demo and just move on algebraically, that's fine. But for some of you, you like to visually see how these answers work or don't work. In this case, the x equals 8. So I'm going to first graph the right-hand side of that equation, which was 6, by graphing y equals 6, which is just a horizontal line. And now I'm going to graph the left side of this equation, which is x plus the square root of x, what was it, x plus 4 or x minus 4? Let me take a quick peek. X plus 4, okay. So the square root of x plus 4, whoops. Let me start over. F of x equals x plus the square root of x plus 4. So the square root can be written as the 1/2 power. So that's how I'm writing it on GeoGebra, raised to the 1/2 power. 0.5 is 1/2. Okay. So there's the graph of x plus 4 to the 1/2 power. And let me just bring this down a little bit so you can see it. And now I want to see, where does that meet the right side of the equation, which is y equals 6. And you can see where these two intersect is the answer. Okay, so if I look at this, I see my answer is a little bit bigger than 3, and that's not the answer I got in number 4. It was actually 5. So I think I made a mistake here, and I did. This first equation that I graphed is not x plus the square root of x plus 4, it's the square root of x minus 4. So let me go back and change that equation, and there you go. You can see that these two lines, these two graphs, the line y equals 6, which is the right-hand side of your equation, and then the left-hand side, which is x plus the square root of x minus 4, intersect at x equals 5. That's where they intersect. That is the solution to this equation. And since this graph and this line only intersect once, you only have one solution. So some of you might be saying, well, why did I get two solutions when I squared both sides? Well, remember, when you squared both sides, let me take these away, you had on one side of your equation x minus 4. So that's just a straight line. So let's put that in. And on the other side, you had 6 minus x quantity squared. So that was a quadratic equation. And when you put that quadratic equation in, 36 minus 12x plus x squared, you're going to get a parabola which will intersect this line in two places, at 5 and at 8. So you see, you've changed that original graph so that it's now a parabola which is going to intersect the line in two places. And that's why you have an extraneous solution in this case. I hope that helps some of you visually see why number 4, the answer to number 4 is just one of those solutions and not both.